So for 1.2, again, there's that word hence. So hence, determine from what you've just done in 1.1, determine the HCF and LCM of those very same numbers, 154, 294, and 216. So please do not, in that type of question, go back and do the ladders again, because that would just not make any sense, because you have all the answers right here. So you are supposed to use that in your next question. So in 1.2, they want, first of all, the highest common factor, and then they want the LCM. So what I would do is just go back and rewrite those products again, so that you have them readily available over here. So 154 was equal to, what was that? 2 times 7 times 11. And then we had 294. That was what? That was 2 times 3 times 7 squared. And then, of course, we had 216. And that was 2 to the power 3 times 3 to the power 3. All right, so now we can see them clearly and right in front of us. So now we can just go ahead and choose the HCF. So remember, the highest common factor is all here about the factors that are common, and we want to choose the factors then basically that appear in all three of these sets of prime factors. So the values that appear in all of them, I think I'll use yellow this time. Of course, it's 2 that appears in all three of them, right? But of course, there are different amounts of 2's. So for example, in 154, we have, this is just 1 2 over here. That's just 1 2, which is 2 to the power 1. This is just 1 2, that's 2 to the power 1. This over here means that's 3 2's. So like we said in the previous memo for class test 1B, we choose the 2 with the lowest exponent, which is then 2, because that 2 can divide into all the 2's that are there. So that would be the lowest. And then, of course, it sounds weird, but it is the highest common factor, because it is the highest number that can divide into all three of those sets of 2's that are factors, because 2 to the power 3 cannot divide into 2. And if I look further, I will notice that none of the other factors appear in every set. So for example, the 7, it appears in the first one and the second one, but not in the third. And the 11 only appears in 154. And the 3 appears in the second number and in the third number, but not in the first number. So the only factor that's common here is 2, and therefore the highest common factor is just 2. So we are done with the highest common factors. So going on to LCM. So for the LCM, things work a bit differently. For the LCM, I need to then choose, of all the numbers, the different numbers or factors that I see across the three sets of factors, and of course I need to choose the highest of them. So for the 2's, I'm going to choose 2 to the power 3, because that's the biggest amount of 2's that there are. For the 3's, I'm going to choose 3 to the power 3, because that's the 3 with the most or the highest exponent. For the 7's, I'm going to choose 7 to the power 2. There's a 7 in, so there's a 7 over here, but this 7 has the highest amount of 7's, or the biggest exponent, so I'll choose that one. Then for 11, there's only one 11, so that's the 11 that I will use. I need to include that. Remember, everything must appear there. So basically, the LCM basically needs of everything. You need a representative of everything. So then 2 to the power 3, so that is 8 times 27 times 49 times 11, and that of course you will need a calculator for. So that will be 8 times 27 times 49 times 11, and that gives you an LCM of 116,424.